This lecture is about an important property of dielectric materials, polarizability. We'll discuss various types of polarizability and their significance in this unit. Polarization involves many motion between the ions, electrons and nucleus, and rotations. We will discuss these effects here. The topics that we will learn here is the dielectric materials, basic concept of dielectric materials, bound and free charges, polarizability, types of polarizability, and significance of that polarizability. With this lecture, student will learn about polarizability, types of polarizability, its significance, and contribution, various contribution to the polarizability. This will also help you to understand the very peculiar behavior of many substances whenever we put those substances in electric field and some applications. Before begin this topic, we must know the meaning of dielectrics. I think we all are familiar with the term conductors and insulators, and we must remember that these two separation reminds you the behavior of electrons specifically. Insulators are also known as dielectrics. Here, die meaning of die is two. Conductors are known for conduction. Conduction means electron can move from the conductors. The reason for conduction is electrons are available in the conductors. Conductors contains large number of electrons, millions of electrons. For example, all the metals. Copper is a conductor, iron is a conductor, aluminum is a conductor, and these conductors have many electrons. So whenever we apply field on these conductors, there is no issue that what will happen to these conductors. Obviously, electron take the energy, and move in particular direction, and it pass the current. We all are using many applications of electricity by passing the current. But the insulators are different. Insulators are known for no free electrons. Electrons are not there in insulators. Whenever I am saying no electrons there means no free electron there. Insulators are just opposite to conductors. They are not having free electrons. Dielectrics have all the electrons, all the charges attached to specific atoms and molecules. And since they are not free to move, they are called bound electrons. Since they are not available for fields, so they cannot pass electrons from one place to another place. However, if you place such type of materials in electric field, the electric field will give some impression, some effects on these charges. We will discuss these effects here in this lecture. What will happen to these bound charges? Free charges and bound charges. Now there are two types of charges. Conductors have free charges, whereas dielectrics have bound charges. Free charges can conduct the electrons from one place to another, but the bound charges can't conduct. So many ways are there by which these materials, these dielectric fields, exhibit changes in presence of electric field. Some of them are like displacement, rotation. The charges are bound charges in the dielectrics. Since these charges are bound, so to be displaced within an atom or a molecule, they can't go outside. And if the electrons can't go outside, so in that case it can be displaced. Yes, there is a limit of displacement. Whenever this displace, they form a dipole. Such microscopic displacements are not as dramatic as rearrangement of charge in conductors. In conductors, the charges are rearranged in a very fast way. But in the case of dielectric materials, the charges which are not free in dielectrics will displace from their position and will be accumulated on the corners. Will be accumulated. And this type of accumulation gives the characteristic behavior of dielectric material. You can learn this by this example. Suppose Suppose you are having atom and the center is positively charged, obviously nucleus is there, but on surroundings we have electrons, and these electrons are everywhere surround this. But if we assume here that this is not having any free electron, and if you put this in an electric field in this direction, then if E is equal to 0, suppose E is equal to 0, so there is nothing here, and if E is equal to 0, no field, then nothing is displaced is there, everything is there intact. But if you put this atom in electric field, and the electric field is in, suppose, this direction, means we are keeping this plate for left plate is positive and right plate is negative, then it gives very special behavior, and the behavior is they become ellipse, where due to this positive charge, the here you will have negative charge, and similarly on right side you will have positive charge. This is the easiest way to explain the effect on dielectric materials. When an electric field is applied to dielectric material, this material becomes polarized, as we have seen in the last slide. Before applying any electric field, the atom that I have shown there is spherical, but on the application of electric field become ellipse. That is called polarization. Polarization means this acquire a dipole moment. Since we know the definition of dipole, we have learned in the previous classes, the dipole means the separation is very small. If the separation between the two charges that will begin here for dielectrics, then if the separation is too small, the separation behaves as dipole. As I have talked about here, one atom, and the electron get displaced in each atom, then this each atom behaves as atomic dipoles, and we have many applications on this. The property of these dielectrics is called polarizability. So I think now we are aware of these terms. Polarization. Polarization means separation of charges. Separation of charges is possible in bound charges. Separation of charges creates dipole, and dipole here is characterized in terms of dipole moment. E is equal to Q into D. Separation between those dipole moment. Basically, the polarizability is a consequence of the fact that molecules, which are building blocks of all substance, are composed of positive charge nuclei and negative charge electron. Now, when an electric field acts on molecule, the positive charge are displaced along the field, while the negative charge displays opposite to the field. This effect is therefore is to pull the opposite charge apart. Yes, interesting word. We must know the the polarization is to pull the opposite charges apart. This can be done in atoms and molecules, but obviously molecules is complex and molecules has more applications. We will discuss later in this lecture. Then the types of this polarization is also important, and from where we can get the idea of polarization. But one thing is sure, that polarization is pull the charges apart. Now, by the previous lecture, we can conclude that polarization is the separation of positive and negative charge in a system so that there is no electric dipole moment per unit volume. This gives the basic definition of polarization. Whenever we give some field, some energy, the positive and negative charge get separated. And separated in such a way the net electric dipole moment per unit volume is there. We have net dipole moment because now there are number of positive and negative particles there, and they join to give you total dipole moment. Polarization now is moved towards polarizability, and polarizability is to show the ability. Polarizability means ability. This is the ability to form instantaneous dipoles. It is a property of matter. I think we can get the idea. The polarizability is the property of the material which gives the idea of ability to form dipoles. Some materials have property to create dipole immediately. However, in some cases, it is difficult to polarize. It depends on many properties. Many, uh, it is maybe the size of the ions, and uh, it's a material property. So it is the ability to form dipoles, and it is used to characterize the materials also. Polarizability, here we are, I'm representing by mu, and this polarizability, this is actually, polarizability is defined as alpha, and this is polarization, and then this is your polarizability, alpha. And this polarizability of the molecule is defined as induced dipole moment per unit strength. Here we should also study the term word induced dipole. Induced dipole means that dipole moment induced in presence of electric field. As is shown in the figure, if there is no field, then there is no separation. But in presence of field, here the left hand side is minus, they have shown, and the right hand side is plus. Then there is a separation between ions. Actually, the electrons are lighter particles. So we should say the electrons are moving. It may confuse you that the nucleus is also moving, but most of the cases nucleus cannot move. And electrons are very versatile. So, and very lightweight. So it moves towards positive plate. Obviously, when electron move towards the positive plate, the remaining will can be explained towards the left plate. Now there exists a gap, and this gap gives the idea or the significance of polarizability. It is convenient to define the polarizability alpha of an atom in terms of local electric field, and this is termed as P is equal to alpha E. Actually, the P is dipole moment, and dipole moment is proportional to E. You learn this, that P is always proportional to E. Now this P proportional to E is equal to P is equal to alpha E, and uh, this is here, alpha is called polarizability. However, if we are working with non-spherical atoms, then the situations are more complex. In spherical atom, we can apply some conditions, but non-spherical difficult. So we will discuss it later how we use a tensor. There are different types of polarization process, and these polarization process are depending on structure of the molecule which constitutes the solid. If the solid has permanent movement, the movement is present even in the absence of electric field. A movement which is present in absence of electric field. we speak a dipole molecule, and the molecule is dipole molecule, and the substance is called dipole substance. We have different types of polarizability in dielectrics, and this is defined as electronic polarization, ionic polarization, and orientation polarization. And finally, we will discuss total electric polarization. Thank you. In this lecture, we will learn about polarizability and cause of polarizability, the types and details of each type we will discuss in next lecture.